morning, everyone, and thank you very much for joining the first ever AFSIA Quarterly Market Intelligence webinar. Um, as you know, AFSIA's market intelligence collection activities are extensive. We have a database of over 45,000 projects that we have tracked across the entire continent. And now what we are doing through this webinar is to draw back the curtain and show you a little bit of what has been going on in the utility scale solar segment in Q1 of 2026. We will be looking at the markets where utility scale solar has been growing, the developers that are working in these markets and leading the development of utility scale solar, the trends that are driving this development, and the technology that is boosting it as well. And we will be looking a little bit later at how advanced tracking systems are maximizing energy yield for utility scale solar in Africa. So, my name is Benjamin Clark, and I am the Director of Operations for AFSIA, and I'm joined today by three brilliant speakers. Rivaal Chowthee, who's the single axis tracker team lead at Lumax. Then we have Gerrit Cronselaar, the engineering project manager at GameChange Solar. And we have Himanshu Sagandhi, Vice President of Sales and BD at Next Power. So before we kick off, a little bit of housekeeping. So in case you were wondering, this is being recorded, and the recording and the deck will be shared with you after the webinar. Then, very important, that using the two chat functions. So if you want to speak to individual participants or groups of participants along the bar at the bottom of your screen, you should see an option that says chat. Now, chat is for speaking to all the other participants. If you would like to ask any of our speakers a question, there is a separate element that says Q&A. So please put your question in there, and then we'll make sure that it gets answered. But now, let's have a look at what's been happening in utility scale solar across Africa in Q1 of 2026. So, as you can see here, there is about in 2026 across all segments in solar, there is about 26.15 gigawatt peak installed across Africa. Now, this is stuff that AFSIA has tracked and verified and is in our project database. And of that, just under half is utility scale solar. Now, the graph that you can see on this slide is the annual installation amounts for every year since 2018 on the left-hand side up to 2026 Q1 on the right-hand side. And now the big story that we have here that I would like to share with you is over the entire 12 months of 2025, 890 megawatt peak of utility scale solar was installed everywhere across Africa. Now, in the first 3 months of 2026, have exceeded that already, installing almost 970 megawatt peak. Now, this rate of deployment is a rapid acceleration, and now we're going to look into which markets around the continent have been driving that acceleration. So, as you can see here, on a regional level, North Africa leads the way. It's installed 672 megawatt peak in Q1 2026, and that's largely coming from Egypt and Tunisia, as we'll see later. Southern Africa is second with almost 220 megawatt peak, and East Africa is third with about 70 megawatt peak. So whilst Southern Africa is the largest utility scale PV region in Africa, what this is starting to show is that growth is starting to become slightly more diversified, and others are making more significant contributions to utility scale capacity in Africa. So, who's leading in Southern Africa? Well, it should come as no surprise to you that South Africa is ahead. It's been traditionally the strongest utility scale PV market. But what we're seeing here is that other countries are starting to make meaningful contributions, such as the almost 13 megawatts that was installed in Zimbabwe, and the almost 19.5 megawatts that was installed in Namibia. Botswana is making a contribution, and Zambia as well. So what we're now seeing is that whereas previously South Africa has been a massive leader and will probably continue to do so, um, we are seeing increased contributions from other countries in the region, which is diversifying growth of utility scale solar. In North Africa, as I was saying, yes, most of the 672 megawatts came from one project in Egypt, and there was a further 72 megawatts in Tunisia. Tunisia has been particularly active recently, and we will go into some of that later. But yes, here we have Egypt consistently leading the way. However, Tunisia is starting to pick up as well, and certainly Morocco has a strong utility scale solar pipeline. Then in East Africa, now Kenya is by far the largest market here, but however, it only added 1.2 megawatts in Q1 of 2026. The main growth in this region came from Tanzania, where Tanesco added 65 megawatts of utility scale solar, and this kind of highlights how important public utilities are for deployment of utility scale solar in East Africa. Other than that, there was not that much movement in the market in East Africa. So, who has been deploying all of this solar, you may ask? So, Scatec, by virtue of being involved in the Tunisia and Egypt projects, has comes out far ahead of anyone else with 672 megawatt peak installed in Q1 of 2026. This is followed by ENGIE in South Africa, where they have a very strong utility scale pipeline that managed to install 180 megawatts. There's several new entries in here, but Tanesco, Solar Century, New Glover Solar, they round out the kind of mid-tier entries. And as I will show on the next slide, there are several new utility scale PV developers entering the market in Q1. So that includes New Glover Solar, who installed that 13 megawatt peak Munyati Solar Farm Phase 1. Sahara Renewables Group, which installed just over 4.5 megawatt peak in Botswana, and Xenon Energy, which installed 2.5 megawatt peak in Zambia. Now, what this shows, combined with the last slide, is that yes, there's becoming a healthier and more diversified mix of players entering the market, from massive foreign IPPs all the way down to more regional and local players. And this is good, and this will help support further deployment of utility scale solar across Africa. So looking ahead, what is coming up? So these are the pipelines of the biggest utility scale solar markets, and these are all projects that have been announced, confirmed, are going through financing at the moment, or are going through construction. And as you can see, the utility scale solar pipeline is massive. It's about 133 gigawatt peak. It should come as no surprise then that the largest pipeline is in South Africa, followed by Morocco, which is about 22 gigawatt peak. However, Morocco is a bit of a peculiar case because there is 17 gigawatt peak across two projects: the X-Links project, which was the undersea connector to the UK, and the Adani green hydrogen project, which looked to put 10 gigawatt of solar in. Now, whilst these haven't formally been cancelled, from the X-Links project, the UK government has withdrawn from the project. So that puts 7 gigawatt peak of solar in serious question. And Adani They haven't formally cancelled the project either, but they have just altogether stopped mentioning it anywhere in publicly available documents, which doesn't suggest that it is in great health. So the Morocco pipeline is more like 5.2 gigawatts, but this is still impressive. So yes, that's the state of the pipeline across Africa. Then I want to look at some of the drivers of utility scale solar deployment. Um, we've identified four of them here, and I've gone into them in very brief detail, but I can share more information if you would like afterwards. Um, for South Africa, which installed 180 megawatts, there is the ongoing Eskom unbundling, the creation of the independent transmission system operator with non-discriminatory access for IPPs. So this has encouraged a lot of IPPs to get into the market. Similarly, the REI4P program remains the major deployer of utility scale solar. In Egypt, there is strong government-backed procurement, including sovereign guarantees for any PPA, which gives developers the comfort to act and invest at scale. Then in terms of public and utility-led programs. So Tunisia installed 72 megawatts. That is its régime de concession or concession regime that has come into effect, that is allowing large deployments of utility-scale solar. And we are now starting to see the wave of what Tunisia has promised for years and years and years, which is large-scale utility deployment. And Tanzania, as I was saying, TANESCO has led the deployment of utility scale solar, highlighting that obviously utilities still have a massive role to play in terms of the deployment of utility scale solar. Cabo Verde and Botswana, their deployment is very, very linked to national programs that they have for renewable energy. Whereas in Zimbabwe and Zambia, for example, massive drought and huge stress on hydropower projects are persuading the country to diversify their electricity supply, which is meaning that they're looking more seriously at solar PV and utility scale solar. Whereas Namibia, it's slightly different. They are heavily reliant on imports from the Southern African power pool. And this means that their electricity tariffs are particularly high, and they would like to reduce their dependence on imports, which is why they are installing utility scale solar. Now, I won't go too much into the VAT rebate on this rebate removal on this slide, because I've got a separate one after this that talks specifically about the China VAT rebate removal. So for those of you, I'm sure you will all be aware, but in April 2026, there is the end of the 9% VAT rebate on Chinese solar exports. So we believe that actually the rate of development, the rate of deployment in Q1 is quite linked to people trying to get their projects finished, or at least begin construction before the rebate ends, so they can benefit from this 9% rebate. However, from Q2 and Q4, the rebate will end, and we expect to see a step-by-step increase in the price of solar equipment, rather than a massive price spike. This is so a step-by-step increase that will have some impact on those utility scale projects that are yet to begin construction. So projects at the financing stage will be most exposed to this, and it's been calculated that around the total project cost increase as a result of the end of this rebate will be around $9,100 per megawatt peak. Now, this is not ruinous, but it is significant. So that brings me to the end of our initial overview of what has been happening in utility scale solar in Q1 of 2026. now it is over to the real stars of the show. Are experts on here who are going to speak to us about how how modern tracking systems are boosting and the deployment of utility scale solar and boosting the efficiency of it across sub-Saharan Africa. So first of all, I would like to welcome Rivaal Chowthee, who's the single axis tracker team lead at Lumax, and will be talking to us about yield optimization and performance enhancement for utility scale solar using trackers. So, Rivaal, if you'd like to share your presentation and switch on your camera.
Thank you so much, Benjamin, for the introduction. Well, let me just share my screen. There we are. Can you guys see my screen?
Yes.
Well, thank you. Okay, so yeah, so my presentation will follow. I'll just give a brief overview of the company, and then we'll take a bit of a deeper look into the tracking systems versus fixed tilt and the optimizations that we usually apply. So the overview of the company is just to give an idea of where we fall in the market and the services that we offer. So Lumax Energy is a solar mounting structure manufacturer and designer. Currently, we look at rooftop structures, ground mount structures, carport, and single axis tracker structures as well. We do have a team of 17 plus engineers, so custom structures definitely fall within our scope. Currently, since 2015, we have in excess of 3 gigawatts supplied to the market. We roughly do around 50 megawatts supply per month. That doesn't take into account your fluctuations. That's more of an average value. So it could be higher, could be lower over some months. Our current BEE level is level 2 as well. So our current value proposition as Lumax Energy is local presence and global equality. We do pride ourselves in our local manufacturing capabilities. If we look at the single axis tracker, specifically, we can achieve around 95% local content. So that will be locally manufactured. We do have strong engineering support. So we do have in-house PR registered engineers. So for your project sign-off, utility scale, we are willing to provide the service of signing off ourselves with the registered engineers. And that also speaks to the point of the custom structures as well. We're more than happy to design custom structures. So it will fit our clients' requirements as they intend. We provide installation and QC, so this will fall more on your fixed tilt and single axis tracker structures, and this is on your bigger projects as well. But we do look at it project by project basis and depending on our scope and availability of our teams. We did see in the market that EPCs do like the turnkey solution where we supply and install our own structures because then QC does fall on us and we take reliability for the construction QC. And as you know that your solar mounting structure does does form the foundation of your solar plant. We also pride ourselves in after-sale service and support. So that's quick turnaround times, effective solutions, and we are willing to support, or we do support our EPCs through the construction life cycle of the project and for trackers specifically during your commissioning as well. And even if there are problems later on while your solar plant is in operation. So yeah, that's just a quick overview of the company. We'll go now to a bit of a focus on the single axis tracker. So if we look at our single axis tracker and if we compare it to a fixed tilt with a similar number of panels, you generally see around a 15 to 20% increase in yield. Now, when we look at that, that will also lower your levelized cost of energy. So that's your cost per kilowatt hour will also reduce, which is good for your finances or your funding if you're looking at the financial aspect of your project. On your energy production, if we look at a fixed tilt, your energy production curve is generally a normal sine wave. So your peak is only seen during a certain time or for a very short period of the time during your day. For a tracker, it ramps up in terms of production early in the morning, and it tracks at your peak for a longer time and ramps down later in the afternoon. So you do get more kilowatt hours throughout the day of production. If we even look at your better land utilization, that will tie back into the yield. So you'll need less panels. And then that also speaks to the point of the rebates that Benjamin brought up, where the VAT, now that 9% has fallen away, that now will play into your number of panels and your pricing for your panels, which overall affects your project costing. So that further motivates the point to go for a tracker for your utility scale projects. This all the 4 points then turns or well directs your higher project revenue eventually. So now the features that we deploy to enhance our optimize or enhance our yield and our performance, or well, yield optimization. This is now neglecting or not looking at your structural or mechanical design, your traditional design or engineering design, where, for example, thinner members or material selection, because that applies through all structures, not just specifically for trackers. So for trackers, the way that the trackers work is generally it runs on an axis. It tracks east to west, 60 to 60 degrees generally. And this is controlled by a tracker control unit, which has an algorithm that is programmed, and your inputs is generally your location and your time. So then there are strategies or additional methods that we can use to optimize the tracking, which affects your yield. So backtracking is a feature that is implemented that prevents overshadowing on subsequent rows. So in the initial iterations of backtracking, when it first came out, it was assumed that your site is flat. But we know that this is not true, especially on your larger sites where the ground can vary in terms of undulations and such. So 2D, that was known as 2D backtracking, only took into account your X and Y coordinates. Now, the algorithm has been optimized and improved to take into account your Z coordinates as well. So your independent, it's actually each tracker row in your site will basically have an independent backtracking algorithm, which in turn increases your optimization. Um, Trackers are also prone to wind loading, so that needs to be considered as well. A weather station with a wind meter is supplied with the trackers, and this monitors your wind speed. So generally, you design to a certain wind speed at a max tilt. For example, let's take 18 meters per second. And traditionally, as soon as the wind reached that speed for a certain threshold, the trackers would go into a safe position. So now this basically renders your tracker a fixed tilt for a certain period until your wind speed reduces. With the iStore strategy, this is more of a dynamic wind store strategy. So instead of setting it at a safe angle, it limits the tracking angle based on wind speed. So, for example, at 18 meters per second, instead of tracking 60 to 60 degrees, the wind speed may increase to 20 meters per second, and then you start tracking at 50 to 50. So your tracking angle is limited. So this still allows your system to track, improving your yield instead of it being set at 15 degrees, which in turn increases your yield as well. And then this also allows for your safety factors and your structural integrity to be maintained at higher wind speeds. Then there's a new feature. It's a bit of a basic feature. It's known as overcast mode. So when the weather is overcast, your sun rays tend to be split. So it's not perpendicular because of the clouds. And this is very difficult to predict, and to calculate a angle where the sun ray is perpendicular to the panel is difficult. So an irradiance sensor will be installed on the tracker, and this will monitor the rays and give you a yield. And then you'll set it, which we tend to see is generally around 0 degrees, but this is not safe for the tracker, as it's prone to wind or galloping. So it'll usually be set to around 5 degrees. So these are the basic three strategies that we employ. And this only speaks to your tracking technology, specifically how the trackers are tracking. And like I've said, this doesn't really speak to mechanical or structural design, as that's implemented across all structures. That's just your general engineering. And yeah, that brings me to the end of my section. Thanks, Benjamin.
Thanks so much, Rivaal, and thanks for sharing all that information about Lumax and the new algorithms that you have in place to ensure
Mm.
that these trackers work better in specific African environments. I would like to move to the next speaker. So it'll be Gerrit Cronselaar, the engineering project manager from GameChange Solar. And Gerrit will be speaking about bankability and financial aspects of projects with trackers on them. So, Gerrit, if you're here, please turn on your camera and do start sharing your expertise with everyone.
Thank you very much. Yes. Good morning, everybody. Good morning, attendees. Right. There we go. Just making sure that everybody is on board with what I'm sharing. Make sure that the screen is there.
Yes.
Right. So GameChange Solar. We're primarily a American-based company from a founding perspective, although we have grown globally quite successfully in the last couple of years. We primarily started in fixed tilt structures, moving over to tracking structures, as of course that is the norm for all utility scale projects. Globally, we've delivered up to now about 58 gigawatts of solutions. Our manufacturing capacity in the US alone is about 35 gigawatts, and globally we also have a manufacturing capability of around 55 gigawatts. And at the moment we are pushing out around half a gig every week in terms of project delivery. So your pipeline that you've shared for Africa is definitely important, and it is most certainly part of our scope that we deliver. Right, moving on. I was asked to talk about bankability, risk management, LCE finance, etc. And the way that I've gone about it is, so me being an engineer, is to see what is finance through engineering. So the first thing that we've talked about and that we've seen already is it's all about the lowest cost of energy, right? So lowest cost of energy, just as a summary, total project cost over lifetime divided by total project energy yield over the lifetime. So the one thing that we can really change in that equation is the denominator, and that's the energy yield. So between all tracker companies, that is exactly what we are trying to achieve, is getting that yield increase by deploying different algorithms, different tools that we have to our disposal to increase that. So an example of one of those that we deploy quite successfully is what we call smart stow, or our progressive stow. So as what was alluded to earlier, is that we don't have a simple one set deployable stowing angle. As the wind increases over range, we limit the tracking angle up to a final stow position. And looking at that, if you compare it to a binary stow, there's quite a significant energy saving or energy boost that we can get from that. What is equally important about these type of functions that we talk about is that we ensure that it is true and bankable. So what is bankability? Bankability at the end of the day is confidence in the asset that you are procuring or the asset that you are building, in this case, the utility solar farm, that it will deliver predictable cash flows over a set period. So in most cases, that would be a 25-year or a 30-year lifespan, but predictability of that energy production is really the key. So what are the key drivers to it? Proven technology. So in our case, we believe firmly in third-party validation of all the claims that we make. So be it for energy yield increases, smart stove, power boost, which was the 3D backtracking, weather smart, which is the overcast systems, our constructability. At the moment, we have the fastest installable product on the market. This has been third-party validated as well between other competitors, or just normal availability, uptime type of studies that we perform. For us, it's really important to make sure that if we make a claim, it's not only a one-sided claim that we are presenting, but that it is actually validated by third parties. So at the end of the day, if we look at it, it's bankability in our case is not about being the cheapest tracker supplier out there. It's about being the most predictable over a 25-year lifetime and being able to meet up to those expectations that we have, right? One of the other items that is extremely important at the moment is risk mitigation for solar farms. So in South Africa, we had a severe hail event at one of the concentrated solar plants where half of the plant's mirrors were shattered in a single event. So of course, hail's taken the local industry in South Africa by storm in terms of, or in the eyes of lenders as well as the developers of projects, because all of a sudden this huge risk has come to the front. So one of the things that I want to make clear is that we really invest in research and development and making sure that we continuously drive the industry forward. One of those things that we've done is we've had CPP, so one of the world leaders in wind design and climatic design, do a study looking at specific hail events and how these happen. So one of their key findings, if I can take it out on this slide, was that there's no single direction during a normal hail event. So in the study that was performed, two separate locations were identified, one in Australia and one in East Texas in the USA, where a lot of data was available. Because one thing to remember is that although we always want to know, measured data is not always that available. So for these two sites that we investigated, if we look at the wind rows or a directionality rows that we have here, what was evident from the study that was performed is that there's no regularity in the wind direction during hail events. So what we see is that in 1 minute interval interfaces, if you look at it in Australia at that specific plant, 75% of the time the wind would shift both from east to west, or generally east to west sectors. And then for the East Texas event, the same was also seen, that for that specific site, we also had 84% of the time we would have a shift between east and west sectors. And the reason we are trying to move this into the market and get it accepted is that there's a let's call it a owner. Let me think what's the correct word for this. There's a current thought that stow does not matter. And some of the competitors have this idea that they will always stow in a nose down direction into the wind. so only having compressor forces on posts. Some competitors stow in a flat position, which is definitely not sound from a aerodynamic or aeroelastic perspective. And then we have our stow strategy, which is omnidirectional, which means that we don't care if there's an up lift or a down lift on the modules. We plan for that single stow direction. And the reason from a hail perspective why this is important is that if you have hail, and we continuously already now know that hail comes from both east and west directions, there's no way that you can always tilt your modules to face nose down into the wind. Stowing flat is definitely also not an option. So the only option is to really stay put and to design for that. So our solution to this that we've implemented is hail stow. We specifically use a prediction system for hail, so no on-site sensors. By the time that sensors are hit on the site, it's of no use anymore. You've already lost half of your plant due to the hail damage. So we make sure that both in a 30-minute and a 15-minute interval, we continuously monitor the weather state around sites, and then we give a command to stow those trackers. So in that sense, we are able to reduce that perceived risk that a lot of these sites have. So that is one more card that we have down on the finance side, is in the long run, can we reduce risk? There are other options that we have available as well. For example, execution risk, making sure that we can accommodate changes in design past after the design's already set, things like that we can do. But the most significant risk that we see at the moment is hail in hail-prone areas. So if we have a look at the summation of it all, firstly, what we want to do, like I said, is increase yield. We've got a few options to use in that regard. Typically, we see around about a 2% increase just by our specific implementation of how we do things compared to competitors. And if you compare it to fixed tilt, of course, we've got about between a 15 and 25% increase in yield. The other lever that we can pull to increase the project profitability is reducing capex. We make sure that the design is highly optimized and correct for the climatic and wind conditions that we have on site. We make use of a lot of pre-assembled parts that are delivered to site to speed up installation times. We also make sure that our design is as simple as possible and still deliver the results. And then we also deploy TopoSmart, which significantly decreases the amount of grading that is typically required on site. Also further reducing other risks such as erosion and water management risks on site. Right. And then the last part that we have is just lower maintenance costs. So making use of digital systems, a little bit of machine learning to do predictive maintenance. As I stated, the hail stow strategy that we have to make sure that there's no ill harm from, let's call it, natural catastrophe type weather events. Making sure that our design is as optimal as possible from a maintenance perspective. So making sure all the components are life rated on the system. And in that sense, we can reduce OPEX. So if we take that all together, what can we do? Firstly, the project internal rate of return is increased due to the faster project timelines that we can follow. And then also looking at the energy cost, we typically see that we have around a 5 to a 15% lower cost of energy, because we can introduce all three these main topics to control that denominator that we discussed during the first part. Right. I'll leave it open to questions.
Thanks so much, Gerrit. Before we move on to the Q&A bit, because I can see there's a few in the chat already, just a reminder to everyone, if you do have any questions, do put them in the Q&A section, and our excellent panelists and presenters will tackle them afterwards. But yeah, next it is my extreme pleasure to introduce Himanshu Shigandi, who's the Vice President of Sales and Business Development at Next Power. Himanshu, the floor is yours.
Thank you, Benjamin. And let me just set this up, share my screen here. And here we go. All right, I hope you can see my screen here today. First of all,
Yes.
let me thank AFSIA and Benjamin here for hosting this webinar and giving us the opportunity to participate. So really appreciate that. Thank you so much. The topic that I'm going to be speaking about today is about digitalization, O&M, and lifecycle management on these tracker system projects that my fellow panelists actually talked about and gave a good intro of what trackers do and how they actually help the overall system. I'll begin very quickly with a quick introduction to the company, Next Power. Right, so for that. All right, so at Next Power, we are the largest technology platform in the utility scale solar space, delivering over 150 gigawatts of products since our inception in 2013. We are ranked globally the #1 tracker solution provider for 10 consecutive years in a row, clocking in roughly about $3 billion in annual revenue. And with over 1,800 employees worldwide across 9 global offices, with approximately about 100 manufacturing facilities worldwide and catering to about 45 countries. We are also a publicly listed company on the US market in the NASDAQ Stock Exchange. So you can find a lot more details about the company in that forum. Without much ado, I will directly go into the concept of digitalization and why it's important for power plants. So Benjamin, you talked today about the growing capacity of projects being installed in the African continent. And let me share this anecdote. When I started my career in solar about 15 years ago, a typical utility scale project used to be about 5 megawatts. That was a big project at that time. But over time, over the last decade or so, we have seen that project sizes have shot up. At average project sizes, typically we see are now hovering around 200, 300 megawatts on an average. We even see gigawatt scale deployments of utility scale solar projects in some of these in the developed markets and the developing markets. So obviously there's a huge thrust on the scale of the projects, the size of the projects. These occupy acres and acres of land. And so the whole idea of digitalization here goes into how do we address these huge sizes of projects, huge swaths of land, while at the same time improving the operational efficiency of this asset that has been deployed in the field. And also avoid or minimize any losses that these plants tend to suffer. That's really the whole forte of digitalization that we talk about. How do we really get into this digitalization efforts? So, it is a very layered approach. At the very base, you had the old mentality. You had a site, but it was not connected. You had field people on the ground who would just try and go into the site, figure out what's wrong, and then try and correct it. So you had no data access, very limited support, and it was very reactive kind of a framework. The next layer of digitalization really goes into, okay, let's get better at this. Let's start monitoring the site. Let's see who needs help. How is a component behaving? Let's monitor it and see what does it really need a help. So it helps us, understand how the system is behaving, but then somebody still has to go in and take some actions. So we've kind of evolved that at Nextracker, in a layered way over time and said, let's get better at this. Let's start diagnosing things. Let's not just monitor and see how components are behaving, but let's start diagnosing them as well. What's really happening? What were the trends that these components showed over time? And is that fixable? The next layer that we've actually evolved into is proactive. So as we've deployed this huge gamut of assets across the sites, we've seen these assets showed typical signatures, and we can actually monitor those parameters to figure out what might actually happen with these components. For example, a motor current is increasing, or the battery voltages are reducing. So what might be triggering these kind of actions? So we get into now another layer of proactive maintenance here. And taking that to a top level is where we could actually go to a prescriptive, where utilizing all this monitoring, diagnostics, and proactive maintenance, we could actually prescribe, like, here are the actions that you could take in these instances. What does this do? It basically helps us, avoid losses on the plant, thereby, enhancing the operational efficiency of these plants, and ultimately reducing the levelized cost of energy on these plants. So that's really the whole gamut of digitalization that we are looking at. Now, how do we really get to this level of efforts? So you really need to start with a very strong base layer. On the tracker side, you start off with deploying these independent road trackers in the field, which have been designed with industry-leading wind engineering and structural design. So very reliable steel structures which are placed in the field. You map them with very reliable components. The motors, the controllers need to be fairly good reliability. These assets need to be performing for 25 years. You also ensure a layer of powering them so that they're not dependent on external sources of power. So each row has its own controller, own motor, own drive system. So you can actually monitor them at an individual row level. We've tried to kind of maintain them very easy to install plug and play systems. So not an extensive replacement of components in case of an issue, just plug and play, remove one component, put a new one, and it's done. And then overlaying this whole architecture with a very reliable communication system, which is wireless. So you can actually get all of this information from these different components, from these different structures in the tracker system, and then it can be overlaid to a digital layer. Now, from there, we move to a digitalization architecture. The whole philosophy here at Nextpower, when we do this digitalization concept, is to have a unified project platform. For instance, the NX1 platform actually enables us to have a unified view starting from delivery of the material to commissioning and beyond, even during the execution and warranty stages, to actually monitor what's happening at the site, what are the actions that need to happen at site, and what kind of support the site needs. We could also look at this from a clarity at scale. As we talk about projects going into 200, 300 megawatts, there's a huge bunch of information that is coming in. So how do you really analyze this huge quantum of information that is coming in? Also look at seamless collaboration of all of these information. You are going to get information from motors, from controllers, from battery systems, from X, Y, and Z. So there's going to be a bunch of information that's going to be flowing through in this layer. And how does all of that integrate, collaborate, and give you a view of how the system is behaving? How does all of this actually give agility to the team in action? Can they utilize this information at the field level and take corrective actions? And then last but not the least, how do you ensure that this whole platform enables a future innovations? There are improvements that will keep happening over time during the course of or the life of the project. So how do you ensure that all these innovations can also be built into the projects over time? That's the whole effort of where digitalization at Nextpower goes into. We've also gone ahead and implemented quite a bit of robotics and automations into these digitization layer. For example, we have these inspection and site inspection robots and early detection systems, which basically are trying to reduce the overall risk of the project, while at the same time maximize the O&M efficiency, using the power of AI. Get all this information from the site, analyze them, and give a view to the O&M team at the site to take corrective actions. So that's really the gamut of the O&M offerings that Nextracker is offering in the market. I'd like to kind of go through a quick example here of one of the sites. Here is a bird's eye view of a 200 megawatt plant. it has different blocks. And with these systems, we could actually go and monitor the site, not just monitor as to what's happening on the site, but take it to a next level and assess what's the issue that is being created. Is that something that can be addressed? What kind of faults the system can detect, and can it pinpoint the actual fault? In this particular case, certain blocks which are highlighted in purple show certain faults, and then the faults can actually be identified by the digital software itself, the navigator. And so what does it do for a site O&M team is, even before they actually go to this point, they are aware of what the issue is, what's the remediation, and then they can go equipped to the exact location in a large site to correct that issue. That's the power of these digitalization tools, which enhance the operational efficiency of these personnel at the site. Wherein the whole effort is really going into tracking what's happening at the site. So you can actually track multiple. Here is an example of how you track the movement of the row, how at angles at different points of the time. You could do it for multiple components, for motors, for batteries, for n number of components at the site. How do you then monitor that and get it into a predictable information? What's happening? Is it normal? Is it deviant? If it's deviant, why is it deviant from the actual behavior? And then get into a layer of track, monitor, but then analyze, like, okay, could it be different? Could it be better? Can it be improved further? Thereby just ensuring that the plant achieves a very high availability for the system. All that really enables is to lower the cost, the O&M cost of the site, thereby improving the LCOE for the site. And that is all I have for us today, Benjamin. Happy to take questions.
Thank you so much, Himanshu. Can I ask all of the panelists to stick their cameras on, because we have a few questions in the chat that I would like to pose you. We got okay. There's no name attached to this question, but it is to all of you. Do you provide any 3P tracking solutions, and are they bankable? So maybe we can start with Rivaal, then go to Gerrit, then go to Himanshu.
Yes, okay, sure. At this point, no, we do not, as Lumax, we don't supply a 3P tracker. So that falls within outside our scope of supply.
That's fair. And Gerrit.
Yeah, so likewise, we are currently limited to 2P tracking solutions that we have available commercially. The question I would rather ask is that increase in cord length from engineering perspective, would that really be beneficial? What are the kind of GCRs that you would look at on a site if you go to a 3P solution, and is there a real engineering reason to go to 3P?
Last but by no means to Himanshu.
Thank you, Benjamin. I kind of second Gerrit on that. From an engineering perspective, from an overall product reliability perspective, I think going into a 3P, which is probably a cord length of more than 6 meters, seems to be excessive, and really need to understand the use case of what is it that is being tried to achieve there. I think from a reliability perspective, having evaluated, we do not offer a 3P solutions in the market right now.
Thanks. I think that's pretty comprehensive. I don't have the person's name because they submitted the question anonymously, but I hope that has answered your question. Someone who has not submitted a question anonymously, Elodie Toto, has said China is ending tax rebates and exports incentives for solar panels and batteries. What impact will it have for Africa? So maybe I can provide a little bit of what we're seeing from AFSIA's point of view, and then go to each of you and see if there's anything else to add. But from our perspective, what we are seeing is that there's a big acceleration of people trying to buy panels at the current reduced price with the rebate, which is why you're seeing a lot of projects push to start construction at this point already, so they can procure the panels at the cheaper price. What that will mean is that there's probably over the course of 2026, there will be a lot of projects that are coming online because they have had to start construction early. Then in terms of price increases from the point where the rebate ends, we don't expect there to be a massive price spike. We expect there to be a step-by-step increase of panel prices that is not as catastrophic as some people might think. Certainly not for the utility scale and for larger CNI. The people it will affect mostly are the smaller CNI customers, the off-grid and mini-grid segments as well, where price sensitivity is far greater. But I don't know if Rivaal, Himanshu, and Gerrit, this is playing out in what you see in terms of your either your order books or what else you're seeing through your companies. I mean,
Okay, I can comment a bit on my side. So once that announcement was made, we did see that a lot of projects were, how can I say, reevaluated from a financial aspect, because your panels tend to be one of the one of the more pricier components on your project. So yeah, it did send a bit of the projects back into review, and but as you said, if they do make an incremental increase to the price, that may help our business case as well. But it also further pushes the reason as to which technology or which structure you are choosing in terms of fixed or tracker for your project.
Thanks very much, Rivaal. And I don't know if Gerrit and Himanshu, you have anything else to add on that front.
I can add a bit of comment there. I think in general, a module price increases definitely helps the tracker case, as Rivaal pointed out. So definitely that happens. However, as it is definitely the module is definitely one of the most important components in the overall system, and any fluctuations there tend to impact the long-term pipelines on projects. So there is probably a little bit of reaction in terms of the development activity that we would see. But from a long-term perspective for tracker systems, it's always a positive.
And that's good to know. Thanks. And I don't know, Gerrit, if you've got any final thoughts before we have to wrap up.
I see there's a bunch of questions for me in the Q&A as well, which I'll attend to. Just on the panel perspective, everybody's looking at the panel price, but as an example, what we see is that there are other items as well. So, for example, if we look at steel prices as well, and in South Africa, for example, there's a recent implementation of an anti-dumping type scheme as well for steel from certain countries. So it's not only module prices that have increased about 20%. There are other factors at play as well, which are impacting projects. Some of them are being expedited on a extreme timeline to try and beat that April date. And other ones have simply either been postponed or they are being renegotiated. So at the end of the day, how does it help tracker companies? We sell more trackers because it's more efficient to use tracking systems compared to fixed tilt also. So yeah.
And then Gerrit, I think there's a couple of questions that apply to GameChange Solar that are in there. So we've already slightly gone over. So can I ask you to keep your response very, very brief? So how does GameChange claim 15% benefit of lower LCOE than competitors, whereas this vetted, especially against players like Next Power?
Yeah, so we make use of companies like Black & Veatch, etc., to perform these studies. I'm not necessarily saying that this is against Nextracker. I think I've got an idea who posed the question in that. But it has been found due to the other methodologies like our TopoSmart algorithms that we run, terrain following, implementation, etc. There's a considerable saving that can be had. Typically, if you implement terrain following and TopoSmart, there's about a 95% reduction in civil costs on the site, as an example. To the other third-party quickest installation, we specifically ran sites. The third-party consultant was Eclipse in the US that did that. And then to the question, projects done in Africa, yes, we all three companies represented here are definitely supplying projects into Africa. And then, yep, I think that's a quick summary from my end.
Thanks, Gerrit. And then maybe one more for all of you, because yeah, someone has put a very concrete case study in here. So to all tracker suppliers, we see difficulties from installation contractors to consistently maintain the more strict tolerances for tracker systems throughout a big site. How do you support the installation contractor during construction to ensure your requirements are maintained? Risk. When trackers fly away, it's always a fight between the installer and the supplier blaming each other. So in in about 10 seconds from each of you, what are you doing to address this scenario that's been raised? Rivaal, maybe you'd like to go first.
Okay, quick one. We support our contractors by a rigorous QC process. I'm not sure. I think this is for all tracker companies. We also provide training and support known as the golden table. So we'll assist the contractor for the first table and make sure that they know how to install it, what to look out for and the tolerances to look out for. So, and then we also support through documentation that will supply on how to install and how to support your installation to be installed correctly. Yeah, thanks.
Okay, thanks, Rivaal. And Himanshu, maybe you can go next and then we'll come to Gerrit.
Surely. I think apart from the trainings that we provide to these installers at the time they're at site, we also depute our personnel at the site during the installation phase, because at project sites obviously we expect issues will pop up, which were not foreseen at the time of contracting. So we depute people at site who are there, who real time in the field, and then providing real time solutions to these issues that crop up on the site. Apart from that, we have a program called PowerWorks, where we actually invite people for these installation trainings on a regular basis. And kind of showcase all the best practices from across the globe in terms of installation.
Thanks very much, Himanshu. And Gerrit, anything to add on this already?
Yeah, so I'm sitting in our training center in Cape Town at the moment. So, of course, proper training to all those involved. Simplified design, not requiring any specialized tools or any specialized skills to be able to install a tracker. I mean, we have to make it as easy as possible and as quick as possible for clients. And then also ensuring that we do proper design. Trackers are not supposed to fly away in the first place. So proper engineering for a start would gladly help in that regard. And then, on-site support. For all our projects, we deploy a site engineer to continuously monitor the installation.
I do my best to note them down and try and get back to you in the meantime. But yeah, for the over 100 people who have attended this, thank you very much for attending this the first ever AFSIA Market Intelligence webinar. We will be holding 3 more throughout the year at the end of each quarter to tell you about a different segment and what's been happening there. I would also like to thank our fantastic speakers, so Rivaal Chowthee from Lumax, Gerrit Cronselaar from GameChange Solar, and Himanshu Sagandi from NextPower. Thank you all very much for joining me today, and thank you very much for those incredibly enlightening presentations. And most of all, thank you for sticking to time.